Hello, welcome back to the Looc. In this segment we continue to discuss various aspects of methods such as recursivity, how to write and use recursive methods, and we also look at how to pass arguments by value and by reference. So starting with recursion, a recursive method is a method that calls itself. A method is capable of solving base cases for which no solutions are available, and then the method divides the problem into two parts, one that the method knows how to do, and the recursive call, recursion step that solves a smaller problem. By reducing the problem size, the recursive method gets closer and closer to the base case or one of the base cases so that it will terminate. A sequence of returns ensues that until the original method co-returns the result to the caller. It's so one of the most commonly presented examples of recursion is computing the value of a factorial. Using the recursive declaration of the factorial, we can write the recursive method for it. Given a positive integer n, its factorial, m factorial, is the product of the numbers from 1 to n. So 3 factorial is 1 times 2 times 3. 5 factorial is 1 times 2 times 3 times 4 times 5. So in general, n factorial is the product of the number, the consecutive integers 1 times 2 times 3 all the way times n minus 1 times n. An important property of the factorial is that n factorial is n times n minus 1 factorial. That's simply by the definition, because n minus 1 factorial is all the numbers multiplied from 1 up to n minus 1. So if we multiply it by n, then we get the product up to n, which is exactly n factorial. And when we use this relationship, then we can write a recursive method to compute the factorial. By doing so, we call the method calls itself recursively on smaller and smaller problems. So, for example, to compute 5 factorial on the left hand side, the method will try to compute 5 times 4 factorial. 4 is smaller than 5. Then it still needs to determine 4 factorial, so it will do so by attempting to compute it as 4 times 3 factorial. 3 factorial is even smaller subproblem that can be determined as 2 times 2 factorial. So we just need to compute 2 factorial, which is 2 times 1 factorial, and 1 factorial is the base case, 1 factorial is 1. And this is when the methods reach the end of the recursive calls, and then the recursive calls now return their value. So 1 factorial value is returned as 1, so 2 times 1 becomes 2, that will be 2 factorial and return. That allows the computation of 3 factorial as 3 times 2 equals 6, that's 3 factorial. Having computed that, 4 times 3 factorial, 4 times 6 equals 24 is returns, 24 is 4 factorial. And having obtained that, multiplying that by 5, 5 times 4 factorial, 5 times 24 equals 120 is returned, and indeed 5 factorial is 120. So this is the recursive evaluation of 5 factorial. The actual code is shown. So in the main method, we just call the factorial just once, actually 10 times. So it's a single for loop, a long integer 0 less than equals 10 counter plus plus, and we print out that counter factorial equals, and then here is where we call the factorial method that comes after the end of the main. And the method is shown next. So it's public static long factorial long number. It could be int for the input parameter, but the return value is better be long because factorial is a very fast growing function. So relatively small numbers have very big factorials, so it will overflow the regular int pretty fast. So the base case is the one we know, the known result. If number is less than or equal 1, we return 1. It might be odd that why is it not equal as opposed to less than equal, but actually mathematics 0 factorial is also 1. And then comes the recursive step that otherwise else we have to return, and this is the recursive formula, the input number times the factorial called on number minus 1. That's a smaller problem, so this will be a method that keeps calling itself. So factorial calls factorial, however every single time on a smaller input, 1 less, until it eventually reaches the base case 1. It is a run up to 10 factorial, and 10 factorial is pretty big, more than 3 million, so that's why we want a long return type. So to write this program in Visual Studio C#, in the main method, it's relatively short, so we write the for loop. So the comment is calculate the factorials of 0 to 10, actually 0 to 10, so it's 11 total factorials. It's a for loop, and counter equals 0, counter less than or equals 10, and maybe pre-increment counter, and then comes the body of the for loop. So and for, and as a matter of fact it's a single instruction, so it doesn't even necessarily need the brackets, so it's a write line, and we display that our first argument factorial equals, and the result is our second argument. So there's the formatting string, and what it equals is counter is the first argument, and the factorial of, not factorial test, but factorial of counter is our second argument, and that's the end of the for as well as the end of the main method. Once the main method ended, we just need to write the actual recursive factorial function. So recursive method factorial. So public static long is the return value because it grows very fast, and int some integer number, and that's the end of the method. And within the body of the loop, first comes the base case. This actually base case is because 0 and 1 is both covered by this. So if number is less than or equal to 1, that includes 0 and 1, then return 1. So that's the known case, the base case. And for every other situation, we need the recursion step. So that will be the else of the if, and in particular we would write that return number times, and now we call the method itself but a number minus 1. And by reducing the size of input, we make sure that the method makes progress, so it will terminate. So that's our code. Let's try to build it. And it completed, so we are ready to test it by running Ctrl F5, and there are the first 11 factorials, 0 to 1, 0 to 10. So here is the output. So fast growing function as an integer, and 10 factorial is already in the millions, and it just keeps growing from there like crazy. And there's the output and the code, which is just a for loop that calls factorial 11 times, and factorial is recursively calculated. Maybe to simplify the code a little, we don't even need an actual body of the for loop, because it's a single instruction body, so it works without the braces. And here is the result again, the factorials of the first 11 integer numbers and the code. So it's a loop that calls factorial for 11 numbers, and the factorial method itself is recursively implemented. A quick comment that it can be implemented non-recursively in a simple loop just by multiplying numbers, and the two are roughly equivalent. However, the non-recursive method tends to be more effective, more efficient from a computational point of view. The last thing so let's talk about a little bit more about recursion. So we determine whether the terminated condition is true, and then if not, we go on to solve a slightly smaller program than the original. If we don't reduce the size, then we can cause an infinite recursion that eventually results in a stack overflow, similar to an infinite loop. Our next topic will be passing arguments, pass by value and pass by reference. Two ways to pass arguments to methods or functions in many programming languages are pass by value and pass by reference. And when we pass something by value, which is the default in C#, a copy of the value is created and passed to the called function. This means that the called method or function actually operates on a copy, and therefore changes it makes to it won't affect the original copy within the caller function. When an argument is passed by reference, the caller gives the method the ability to access and modify the caller's original variable. Pass by reference can weaken security because a called function can corrupt the caller's data. On the other hand, it's often necessary to use it, especially when a large amount of data is passed between the caller and the called functions, because creating a copy in case of large amounts of data can be expensive both in memory use as well as can take a long time. To pass an object by reference into a method, we simply provide it as an argument, because objects in C# by default are basically passed by reference. In the method body, the parameter will refer to the original object in memory, so the called method can access the original object directly. Meanwhile, a pass by value type variable is passed as a copy, and those variables are generally the simple native types, so integers, float, double, boolean, and so on, numerical types. When we pass a reference type variable, then what really happens is that a copy of the actual reference is passed. So by the reference itself is passed by value, so a second copy of the reference is made, but that reference refers to the original object, and therefore the called function can modify the original object. A return statement returns a copy of the value stored in the value type variable, or a copy of the reference stored in a reference type variable. So passing and returning can both happen by value and by reference. And in effect, all objects are always passed by reference, because objects are reference type variables when they are assigned to a variable, and even though the reference itself is passed by value, it still references the original object. We can change the default behavior. The ref keyword can be used to pass a variable by reference. In case we have a value type variable, ref will always make it to use by reference, and it can be used for values that have been already initialized in the calling method. We can modify it by the out keyword, which creates an output parameter, and that indicates that the argument that will be passed by reference will be assigned a value within the called method, and as a result it can be passed even when it's uninitialized. So some examples of that. And when we pass it by a reference parameter ref or out keyword, then in the implementation we have to implement it accordingly, and we have to precede the same keyword when we are calling the method. So they must match the method declaration, otherwise a compilation error occurs. Generally, C# does not allow the programmer to choose which way arguments are passed. Value types, which are typically native symbol types, are passed by value, and uh, objects themselves are not passed to methods, but references to objects are passed, and these references themselves are passed by value, which amounts to passing by reference, because the called method can manipulate the object directly, but the reference value itself cannot be changed to refer to a new object, and there are ways to pass references by reference. It's the end of this